In this video, I want to talk about LeetCode problem 1061, lexicographically smallest equivalent string. This is today's daily challenge problem on the LeetCode site, and there's actually kind of a funny story about that, because this was originally a premium-only problem, so when this was the daily challenge, a lot of people freaked out about it, and they were like, what? Why would you make this the daily challenge? I don't have premium. And then I guess it was a mistake because a few hours later, this problem has now been made public for everyone, so that's cool. Anyway, this is a pretty tough problem. In fact, it's so tough that even the prompt, the description of the problem, apparently confused a lot of people. Probably at least partly because the problem doesn't explain what lexicographically means. But basically all that means is it's just referring to the alphabetical order, right? So A is lexicographically the smallest possible letter, since it's the first letter in the alphabet, and Z is the largest one. If we have the letters B and C, B is lexicographically smaller than C. All the problem means when it asks for the lexicographically smallest equivalent is just saying that if we have a situation where we have different possible answers, we go with the one where all of the letters are as close to A in the alphabet as possible. Anyways, the rest of the problem is described pretty well. We have two string inputs, S1 and S2, which are supposed to be equivalent. So they're the same length, and the letters in each one that are at the same positions are supposed to be equal. So basically just think of them like variables. So the first position and both strings are equal. So A is equal to C here, but since C also appears in the third position, that means that C is also equal to E, which is in the third position in the other string. So it's just kind of a fun little key thing where we can write down little groups or sets of all the variables that are equal to one another. And we use this equivalency information to modify the third input, the base string, to get us the version of the base string that is as lexicographically small as possible. So again, pretty tricky problem, but I think the easiest way to do this is to use a method called the union find method, which is pretty useful for dealing with little groups of lists of values like this, and manipulating them when they're in little sets and creating those sets. I'm going to use Python3, so let's get to coding something. So first off, let's go over the basic crux of what our approach is going to be. We want to do a thing where we have a result string, and it's going to start out as an empty string, and we're going to go through all of the characters in the base string. So I'll say for C in base string. And we want to write some code earlier on that's going to actually look at all the characters in the base string and check each and every one of those characters and decide whether or not it will need to be replaced with a letter that is lexicographically smaller. I'll get to that in a sec, but for now, we're going to append to results something, and whatever that is, we'll figure out in just a moment. But once we've gone through all those characters and done all that, we're then going to end up returning result. Though this approach will actually return a list of strings, one for each character, so we're going to join them together using the join method like this. As I mentioned already, we're going to do this using a method called the union find method. The union find method is pretty common, but if you aren't super familiar with it, or you're not sure how you apply it in this case, I'm going to briefly summarize it. There are a lot of different ways to do it, but generally speaking, it involves initializing some hash table and populating it or modifying it using two functions called the find function, which takes one input, and the union function, which takes two inputs. The basic idea here is that the find function is going to be finding the roots of the elements in the parent table, while the union function is going to be the one that will actually take the contents of these two strings and match up the characters that need to be matched up. In the case of this problem specifically, we're going to use the find function to build up this result string, because that would, I think, be the easiest way, the simplest way to do this. This hash table is going to pair up letters from one of the strings with the lexicographically smallest letters in the other string that it's equivalent to. So it is from this table that we're going to be appending to our result from. So within this append, I'm going to say parent, and then we'll call the find function from here with C as the input. Since this function is going through every single character in the base string, let's have the very first thing this function does check to make sure that X, or the input, is actually in the hash table. And if not, then we can just add it. So if X is not in parent, then we'll just say that it's equivalent to itself. But if the value already exists and that isn't the case, then we're going to change the value of X itself and replace it with the parent of X. Now, if you're watching this and you're wondering what the heck I'm doing right now and you have no idea what I'm doing, the idea here is that this bit of code right here will only be executed when we've gone through the base string and we've hit a point where the character can be changed with another equivalent one that's lexicographically smaller. Of course, we haven't actually written the code yet that establishes that this will be the case. That's going to happen in the union function. But once we have established that, and we hit that character in the base string, then we want to change the value of X itself, so that that character is replaced with a new one that is going to be smaller. So let's actually write the code that establishes this in the union function. But first, we need to actually call the union function, and we're going to do that before we even go through the base string, because I specifically want to call it for each character within the two strings that were given. So because I want to make a set out of all the characters in the two strings, I'm going to put it into a zip function and say S1 and S2. And for each of those pairs of characters, we call the union function. Now we're ready to fill in what we actually want the union function to do. As we typically do in the union find method, we call the find function within the union function to get the roots for each character. So root A, I'm going to call it RA, is equal to the find function for A, and root B is equal to the output of the find function for B. And for each character, we want to replace the parents of those roots with the minimum of the two letters. Remember, we're trying to find the thing that's lexicographically smallest here, and fortunately, Python can figure that out just from using its minimize function. Like if we were to take the minimize function and put A and B in there, it's going to know that the answer is A, because A comes first in the alphabet and is therefore seen as having the smaller value. So all we need to do here is say that the parent of RA and the parent of RB are both equal to the minimum of RA and RB. So whichever one of those characters is smaller, or whichever one is lexicographically smaller, that's the one that's the parent for both of those values in that set. So let's go over real quick what this code we've written does. This part is going to execute first. This for loop's going to execute first and call the union function. And that's going to populate the parent hash table and fill it with sets that map any relevant letter to the smallest letter. And then we're going to go through the base string and for each character decide whether or not we want to replace it with the one that's going to be smaller. So let's run this and see if it works. And it does. Now let's try submitting it. And that's our answer. And it beats 98% of solutions speed-wise and 94% of solutions memory-wise. Sweet. So that's all for this video. I hope you found it helpful. If you have any questions, please leave a comment down below and I'll do my best to help you out. If you have any further comments or requests for future videos, I have a Discord server linked down below and I'll try to help you if I can. But that's all for now, and I hope you all have a good night. Bye-bye.